Hello, how you doing? It's MrDoTheMath here, and today we're going to talk about the Pythagorean Theorem. Pythagorean Theorem. Say it with me. Pythagorean Theorem. All right, good. So, Pythagorean Theorem is what we use when we're trying to find the measure of a side of a specific type of triangle, and that is a right triangle. All right? We use Pythagorean Theorem when we're trying to find the sides, a side of the right triangle. Okay, so here's some important things when you talk about Pythagorean Theorem. Make sure you got your notes because I'm going to go over identifying these parts. All right, when you're talking about a right triangle, you're talking about a triangle with a right angle in it, right? So here's a key concept. In a right triangle, the side that makes the right angle, those sides are called the legs. All right. What are those sides called? The legs. All right, good. Let's make sure you're paying attention. Those sides are called the legs. The sides that make the right triangle that make the right angle are called the legs. Now, the side opposite to the right angle is called the hypotenuse. What's that called? Hypotenuse. Let me make sure I spelled it right. C-E. Hypotenuse, right? That's the side opposite the right angle. Okay, so you have the legs that make the right angle, you have the hypotenuse furthest away, and the hypotenuse is always longer than the legs, right? The hypotenuse is always the longest side of a triangle, okay? So, now, let's see what else we need. So we got the legs and we got the hypotenuse. Now, when you look at parts of a triangle or a right triangle, you can identify the points. And you also identify the sides. So if this is point A, side A is going to be opposite. If this is point B, side B is going to be opposite. And if this is point C, side C will be opposite. But so for the sake of our let's do it this way. All right, so you got B here, and then we got C there, right? Everybody good with that? All right? So that being said, let's look at the formula for calculating the measure of the sides. So what would happen is you would use this formula, and this is the formula you're going to always remember for the rest of your life, whether you're thinking about math or not. Pythagorean Theorem is known as a squared plus b squared and it equals c squared. A being one leg squared plus the other leg squared equal to the hypotenuse squared. Okay? When I say one leg and the other leg, that means that what I'm saying is the A and the B are interchangeable. All right, there's no specific order in which you put these two parts, right? So this could be A, or this could be B, this could be A, or this could be B. Yes, sir?
So at the bottom, the A to the C is the line, right?
Say it again.
A to the C is the line.
A to the C, this right here?
Yeah, the top.
No. This is the name of this point here.
Okay, all right.
And this is the name of this point.
All right.
And this is the name of this point. So if, like, when you get ready for geometry, this would be side CA, right? This would be side CB, right? And this is side AB. Is that what you're asking?
Yeah.
Okay, yeah. That's what that is. But this would A, B, and C represent the measurement, right?
Mm-hmm.
So B is the measure of this side. A is the measure of CB, and C is the measure of AB. That's what that represents.
Yeah.
Okay, we good?
Mm-hmm.
All right, so now let's look at some examples. Now, the reason that Pythagorean Theorem is significant is because we have to take the square root at the end. Okay, so let's look at some examples here. All right, let's label this triangle and solve for it. Okay, let's make it a little bit bigger. Okay, so we got a right triangle. All right, if I say this side is, give me a number.
3.
I heard 8 first. And right here?
3.
5 came faster. Alright, and if we're trying to find C, right? Trying to find this measure C, or we could call it X, it doesn't matter. This is the unknown. The measures of the legs are 8 and 5. So to solve for it, you would have 8 squared plus 5 squared equal to C squared. Okay? And when you're squaring something, you are multiplying it by itself. So 8 times 8 is what? 64 plus 5 times 5? 25, and that's going to equal C squared. So now you add these two together. So you're going to get what? 64 plus 20. Say it again. 89. 89 equals C squared. Now, this looks like what we've been working on. So from here, we have to solve for C. So in order to solve for C, what do, Trey? You take the square root of both sides, right? You take the square root of both sides. So C squared becomes C, and the square root of 89 is what? 9.4. Okay? So now the measure here is 9.4. Okay? Now let's look at another example. Yeah, what's up?
So can you do one list like it's not C, like you find it either A or B?
Yeah, that's what we're gonna do right now. I'm glad you asked. Alright, let's turn this way. Let's look at this triangle here. Alright. Let's see, let's say that this is 10. Thank you. And this is let's say this is 6. Let's see what happens. Okay? It's the right side. Okay? Again, your hypotenuse is 10. Right?
Yeah.
Leg is 6 and your leg is B. Okay? So now this is how you set it up. Yeah, let's do B squared plus 6 squared equals 10 squared. It's important that you always put the hypotenuse on the right side of the equal sign. Always make sure the hypotenuse is on the right side. Okay? So now let's simplify this. 6 squared is what?
36.
36, and 10 squared is 100. Okay? Now, how do we solve for B here? What's the next thing? Subtract 36. Very good. You subtract 36. Alright? So now B squared equals 64. What's the next step we do? Take the square root of both sides so we can get rid of this B squared. So now B equals 8. Okay? B equals 8. Alright? So now this side is 8. Notice how all of these sides are whole numbers. You got 10, 6, and 8. Right? Since all of these sides are whole numbers, they're not decimals, this would also be known as Pythagorean triple. Pythagorean triple, right? Triple meaning that all of the sides are whole numbers, and it's a right triangle. Okay? Now let's look at one other example. Let's come back here, Jeremy. Let's go to this triangle. Okay? And what if I say that the measure of this is, say, 45, the square root of 45. That's the square root of 45, and I'll make this, say, 5, and we're trying to find this side. All right, let's do it. Let's call it an x. Okay? We do the same thing, right? So the first thing we need to identify is what's the legs? What's the legs in this problem?
5 and x.
5 and x. These are the legs. So these will be on the left side. So you got 5 squared plus x squared equals the square root of 45 squared. Okay? I'm glad we're looking at this because a lot of us get thrown off when we see the square root on a measure of a side. Okay? First things first, let's simplify. So you got 5 squared is what? 25 plus x squared equals the square root of 45 squared is what? 45. It's going to be a straight 45. That's it. The square root of 45 is, the square root of 45 squared means that this squared cancels out this radical. So now you're just left with 45. Okay? So keep in mind that the square root of 45 squared is going to be 45. And if you want to check that, put this in your calculator. You'll put square root of 45 here, and then you put squared. And tell me what you get.
I still get a decimal. I mean,
Yeah, 45. Yeah. All right. So now we got 25 plus x squared equals 45. What's the next step? Subtract what?
25.
Good. Subtract 25 to both sides. Right? Bam. And then, so you'll have x squared equals what? 20. X squared equals 20. So how do we solve for x? Take the square root. Right? So you have the square root. So x is going to equal
4.40.
what you get?
Plus minus 2 to the square root of 5.
Oh, you broke it down to a simplest radical. So you got 2 root 5 plus minus 2 root 5 or what? 4.4. Is it 4.4 or 4.5?
4.5. It rounds to 4.5.
Yes. So now, if you're gonna give me the 10th place, you're around. So it's 4.5. Now, I heard somebody say plus or minus, right? Because we're talking about, so typically when we take the square root of a number, we do have a plus and a minus. But because we're talking about now the length of a side, we can never have a negative side length. The answer is going to always be the positive version of that line. Okay? All right. Any more questions? How do we feel about that? Is that cool? That's cool? All right. Don't forget to like and subscribe. MrDoTheMath out.
Hey.